Dun, 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 dun. Oh, hey, there you are. Thanks for stopping by. It's good to see you. We're gonna start just at the beginning, at the beginning of the beginning, and we're gonna take a long, slow walk through not just development or base theory or small application hello world, but what does it mean to be a front-end developer, a back-end developer, an API developer, cloud? What does it mean to then move to a full stack developer, or more likely today, a full IT department? I mean, read some of these job descriptions. Now, the way that we pull this off, the reason it is kind of okay to say some of those things or do some of those things is because we assume there's a healthy understanding and reliance on healthy object-oriented principle design patterns and functional design patterns and aspect-oriented design patterns, the 5 different flavors of databases, and that all of these are generally being brought together in a code-first model in a way that cleanly moves through a DevOps pipeline. And if you know all of the things, if you really at least have seen everything it takes to be a full IT department, at least then when you're on a team and you're serving as a member of a 4, 5, 6 person team, you definitely can bring an 80% wide offering, and your teammates will help fill in some of those gaps where you were less inspired or motivated or didn't necessarily feel you had the skills or chops to do some part of the full IT development. Well, let's move right in. We're going to do something much more fun than a hello world. We're going to follow and stick with one example through the entire time, and we're going to just start day one very simple and learn and explore some very perhaps boring concepts to some of you, but it'll give us a good foundation to build upon. And then we're going to come back every session and ask a different kind of question and challenge our product to grow in a different way until after 12 or so sessions, maybe we've gotten to a point where there is a full expression of something potentially shippable and protectable and deployable and understands the entire scope of what it takes to get from zero to done. So what you see here is Visual Studio Code. If you're not already in VS Code, stop, go look something up and figure that out. You're going to want to get reasonably, on a 1 to 10, you need to be a 2. So make sure you can open VS Code, make sure you can get in, you've got the .NET Core framework installed, you've got all these other things installed to get a very simple .NET Core app up and working. All right, if we've done any of this correctly, we should be able to just ask the .NET CLI to spin us up a new application. This application looked at the folder we were in, created us a CSPROJ, a class with a static void main, which will be important. We'll talk a little more about it. And then hopefully we know by now these 2 folders are actually just part of what's produced when we create our output. So starting with just these 2 files and sitting on top of something like the .NET Core, and we see a very minimal description here. Sure, it's still XML, but almost all of that is gone. Pretty much all of it is gone. The rest of this you'll see is JSON, or at least JSON friendly. And we've just described, I want an executable for output, and here's the framework that's installed on the machine with the SDK that I'd like to use whenever I choose to compile. Right now, the class has been made available, or will be made available when it compiles, and we see that all applications have a single entry point. So we'll follow that a little bit. We're going to kind of set it up and forget it for a while. But here we go. We should be able to run this. First, I'll build just so we can watch what happens. It puts the bin folder with your DLL library, and then the executable, it wraps it in. And we could be able to run it. Hello world. Awesome. Welcome to day 0. I'm going to add a couple of files, maybe even just one, and make it a little more interesting before we slow down and start to talk too much about things. I'm really a big fan of let's do it, talk a little bit about it, do it again, and then let's learn about it at a point when we know a little more and we have perhaps an opportunity to develop better questions. All right. First thing I want to do, I'm going to leave this guy alone. We're going to come out here and look a little bit at our folder structure. And I'm going to back up a level, yeah. What do I want to do? That's not true. I won't be all dorky. We can do it all over here. In folder. This folder. I'm going to separate some things out a bit. So this will be our product, word search. Let's just have core. And let's not build things we don't need yet. Now I happen to know that's going to fire up not what we want. Let's go grab what we want from our shields. So one thing to notice in VS Code, if you double click a file or edit a file, it actually opens. If you just touch a file, we can see it's italic here. It's not actually open. If you were to drive away, it'll go away. All right, so we're in core here. Let's start out with something very simple. Let's figure out how this whole word search is going to kind of lay out. So what is this going to be? Let's just have a few things here. Oops, pick a language. So I pressed Control period or Control space. Control space finishes IntelliSense, and Control period is doing its best to figure out what class I think I'm trying to get to so it can import it. Maybe here it's just called a GUID. And it is in system. So we didn't need it. And we can see that. By looking in system. And we see GUID. Cool. If I delete system as an import, it'll go back to me in SAD, Control period. And we have those two choices, either prefix it or import. Oops. Either prefix it or import. Okay. And we'll talk a little bit more about these using statements and namespaces and things, but let's get a little bit more of an interesting example at first. Let's have this thing. Well, let's just stop there. So let's say we have this idea of a GUID and a lobby. Let's clean up our name here. And we need to do one more thing so that these guys know about each other, so they can talk to each other. And before I do that, I want to clean up. I'm going to call it. Goes there. Whoa, stop. Try those. Feeling better. Now, we need to do a little something here. And that is a project reference. Let's see if I can't get IntelliSense working here. Web folder. Let's go make sure that's what we expect it to be. We'll clean this up while we're here. Clean up some namespaces real quick. I see, we've created a little bit of a collision here. Okay. A little better. We should get our IntelliSenses happy too. Let's get these up side by side. Console over here, core over here. Everybody's happy. Cool. We're gonna change the folder we're navigated to. This will continue to help IntelliSense have a fighting chance at keeping up with us. Everybody's still happy. Word search, word search, word search. I'm gonna keep it all nice while it's little. Cool. Windows back up. So Control Shift tilde says give me a terminal, and as you learn those on your machine or forget about them, you'll find them generally trying to retrain you over here, even though this is telling me something different. Console here, core here, everybody's still happy. And now in here, what we're gonna do, set up core game. And let's bring core in. All right, let's slow down and play a little. Cool. So now we've done a little something. Set up core game. We don't have an instance to self. to talk about already, and we haven't gotten very far. All right, let's see if this wakes. Technically, we should only have to mess with this guy for a bit. He's gonna run build, restore, then he's gonna run build, he's gonna go over to that other dude, do the same. And all of a sudden, we have something. All right, let's chat. First, top of this file. Let's start with this more boring file. We have a using statement. A lot of you would know these as import statements or otherwise. Most of the time, they're referencing an external DLL or library that you've referenced in your project. And you're just bringing all the things in that library's namespace that you've mentioned here into scope within your class file. Static classes and static members will be, instantly available. Think about the math library. You never new up math. You just call math.add. That's because math is a static class. So static classes basically implement a singleton pattern, but singleton classes tend to be instantiated and managed, and there will only ever be one in memory ever, but there can be none, if I get that right. Whereas static class is instantiated much earlier, and there can and always will be exactly one. True singleton class objects are also treated more like first class object citizens and can be passed around and scoped and things done with them. So generally you're going to look to singleton pattern, but there are moments where the static class may serve you. So anyway, the non-static stuff needs instantiated, whether you're newing it up, as we'll do for the first few lessons, or whether you're depending on inversion of control to, yielding that to some dependency injection container. That'll be up to you. We get fewer and fewer new statements as we move on. We'll do a few here early. So the next thing we see is the namespace. And so sometimes these using statements are going to reference ourselves. So let's say if we were in word search core and we had a folder called models, and we created a class here called web user. Come back here, we might want to do models, and then that would be available. So these using statements are either referencing our own DLL, air quotes, our own library, and when we reference within ourselves, it's that namespacing, or we're referencing other libraries we've imported and mentioned in the CSPROJ file, so NuGet could pull them down, and then we're just referencing namespaces within those libraries so that they're available. So we namespace to organize and make it easier for different projects to import smaller and smaller parts of ourselves. Lots of other reasons to organize like this. And 99.9% of the time, this should match your folder structure. So if I'm looking at a namespace, I should basically be able to go find that code. Just like we saw here, models, web user. And so the namespace even wanted to and did that for us, right? All right, so now we have gone into a class. It is public, which means it's available outside of our DLL, certainly available inside of our DLL. Protected means it's globally available inside of our DLL, but not outside of our DLL. So private classes are going to be private within the namespace that they exist in. All right, so then we see some public member variables, public member properties, public members. So these properties are us saying publicly, if you're talking to my class, you can certainly ask about my GUID and my lobby. And then we have these default public initializers that are saying, and by the way, you can get and set me. We could eliminate the ability to write. So now it would be read only outside of people within access to this scope or this namespace. And this is simply shorthand. What you're going to do more commonly is probably something like this, and then here, and you would something like we could again leave that private, and we wouldn't have to implement it. If it's public, then we could say values the magic thing coming in. And we would say, this. All right, what do we got? And I'll call Now, the reason you might want to do this longer form is on the outside, it looks identical. We just have GUID, and it has a public getter and setter. On the inside, our implementation of returning or setting or thinking about if it's okay to set or return, do you have permissions, is it formatted correctly, is my system online, on and on and on and on, you have an opportunity now to get involved in the conversation. Either way, you're going to have to recompile some code if you want to make changes at this level, likely. So refactor as you go, mature your code as you go. Just know that this idea of, anytime you come across such syntax, it's often hiding a lot of behavior that you'll want to know about, you want to learn about. And so as you grow a sense of magic and mystery, continue to make personal goals to dispel the magic. If you can learn 4 or 5 new pieces of magic every day, that's great. And it helps you, in a lot of different ways. And it really gives you a stronger confidence over the system, right? We started with 2 files. We still basically only have a few files. Those can go away. So it's a great time to learn. So our project so far just consists of this, and these 2 are, kind of just describe the underlying getting it ups and runnings, and as we begin to import other libraries and we want to do other things server side, we'll continue to grow this CS_J to describe those NuGet dependencies and get those imported for us. Cool. So we have an entry point. It says hello. We have another project we stood up that houses some future business logic, where we ultimately, for now, just describe this. Let's make it just a little more interesting before we finish here. Let's declare a method on this class that says, tell me your name. Doesn't accept any parameters, and it returns this .GUID. Here, let's play a little with strings. Return. And we have this new come on for a little, that's good. We have this new doodad. It allows us to say, we want to respect our own level variables there, and then we're going to put something else. So not only am I getting IntelliSense, but you can see syntactically this is pretty nice. It's sort of an embedded, uses tuples, what is that called? I don't know, but it's pretty nice. Again, you could write that long form, longer, and you can stack things. So if you wanted to ignore special characters, or if you wanted, there's a character in here somewhere for line continuation, these kinds of things, you just tag them all together at the front. All right, So let's do two things. First, let's add a little conditional logic. That's always fun. If this dot good is null. Now, we have a problem here. We'll come back to. If this dot is good, then return. I don't know what you want from me. Nobody wants a robot that yells. Else, we'll get down to this line. Return statements always exit. In this language, anyway. Know your language. All right, so tell me your name. Is going to try to do this. Now, I don't think we'll ever hit this because, yeah, I deleted all that code. If we had that logic before that instantiated null values to a new GUID, that's not actually a very nice behavior of my old code. All right, so now if we come back to the console and we stop doing that, and instead we want it after we instantiate it, we want to say game, tell me your name, and since it's a function, we call it. Right? This executes that function. In this case, we're passing in no variables. We could pass in things. We'll get to that later. All right, and then we're going to come down here and we're going to do the same. And what we should get is a different result. I don't know what you want from me and my actual name. So it did not know what we wanted from it. Did not respect my authority. I deleted all the fancy codes. Cool. Not cool. So, GUID, if this GUID equals GUID dot null. Nope. Empty. My bad. I don't know what you want from me. Cool. So we didn't get very far in the world of sports, but in the world of building up a foundational understanding, everything else we do builds on our desire to separate out certain kinds of code, give lots of little robots different jobs to do, where they get super opinionated and a little finicky about wanting to mind their own business and protect themselves from the outside, and a lot of cool stuff to follow. And then what you see as we move all the way out to web APIs and Lambda serverless functions and blah, 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 at the end of the end of the end, at the other end of all this, as you move out to all that, it's this same desire, the same thing we're going to tackle in the next lesson, where now I have a library and I want to grow it and mature it, and I want several libraries and I'm bringing them all together and different projects are using them in different ways. My desire to share my own libraries with myself starts to grow. And certainly by lesson 3 or 4, as we start to look towards technologies like web APIs, we recognize all it is this same moment where we have a DLL file and we want to be able to call it from another machine or let thousands of people call it from other machines. And so it turns out the easiest way to stand up some business logic and to expose it as a library that could be reused over and over again by lots of products and lots of technologies would be like exposing it as a web API. But that's slow and burdensome and can be expensive. And so we're going to build slowly towards that need. We're going to stay really close to home and never get too far ahead of ourselves. And we can see when we execute those shared DLLs like we're doing here today locally, and we can literally point to that DLL file or to that project file that gives us the DLL file insanely fast. And every time we try to share it wider and wider and wider with ourselves or other developers that want to take advantage of some of our business logic or some of our back-end access, et cetera, so on and so forth, we move the journey through web API into serverless functions and all of these other kinds of great things where we'll end. So today was all about just classes. just not even really smart or useful classes. But if we don't stay here a minute and begin to fundamentally understand your programming language and the fact that probably everything you do inherits from object. What is object? Well, object is helping deal with all that silliness and memory management and all. It depends on your language. It's doing lots of things for you, but you inherit from a base class of something. And we're going to get into inheritance in our next few lessons. But at the beginning of everything you'll ever do is something of a class or like a class. And even if you're in a language that only fakes classes, I mean, take a look at this. Across the board, we have C# classes, the ones we're writing, TypeScript we'll get into, first-class citizens. Here's Unity and classes and how we all inherit mono behavior and what we do with that and what we get from that. Here's Java and its idea of classes. These are all first-class citizens. You get to Python. Python supports classes. Python is a tough deal. It gets a tough rap in a lot of circles because it's so easy to write really not good code. And if you're only writing like 16 lines of it and you're never going to grow it and you're never going to sell it and it's just going to shush up and do its thing, great. But the minute you look down, you've got 200 lines of code in one file, let alone more, or spreading around the mess and not doing it right. It's time to stop and mature and really think about, what does this programming language want from me? How would it want me to grow and mature at the right levels, at the right scale, and the right times to solving the right kinds of problems? And so it must be important. Here's C++, and I don't even know what this is. Visual Basic, and what are we doing over here? Like Ruby, on and on and on and on and on. All these languages come here for a reason. And today, we got a taste of it. We created a base class, we got a project up, we used a little .NetCore magic, and we saw the very simple structure that it takes now. And everything we've built today works natively on Linux, Macintosh, and Windows. So it's a great platform to start in. And we're going to start to build up both our business classes and our core infrastructure, and then we're going to begin to express it through like an Angular project. And ultimately, we're going to see how we could have different websites, different APIs, different deployment models. We could go with a native app, we could build a mobile app, and all of them reuse most of our base smarts, so that each layer only becomes responsible itself for a couple of lines per file, just kind of here to do my job. I don't want to get all messy and start doing other jobs. And we're going to really get a strong sense of what that means and what that feels like. Thanks for being here. Thanks for hanging out. I hope you were entertained at worst and inspired to go get educated at best, because I'm not the one to do that. But I can definitely give you a taste. And I think it's important to explore the whole landscape and get messy a little bit, to develop better questions. Stop worrying about the answers. Stop worrying about your framework of choice or the language you love the most, and develop really beautiful questions, and let honoring that question move through the 100 different robots you're going to encounter, and make sure you ask them each step of the way, what do you prefer and what would you like me to do, and at what level do I need to mature in what ways? And that's what we're here to do together. Have an amazing rest of your day. I'll see you next time. Cheers. Bye-bye.